Question: DS. In a certain class, there are 100 students, of which 60 students are girls and 55 students have brothers. What is the number of boy students who do not have brothers? Condition 1. 30 students are girls who have brothers. Condition 2. 30 students are girls who do not have brothers. Solution. Now we will solve this DS question using the variable approach. DS question with 4 variables and 3 equations. Let the original condition in a DS question contain 4 variables and 3 equations. Now, 4 variables and 3 equations would generally require one more equation for us to solve for the value of the variables. Complementary 2 by 2. This type of table has sets that are complementary to each other. They are frequently seen on the GMAT. The 2 columns are complementary to each other, and the 2 rows are complementary to each other. We know that each condition would usually give us an equation, and since we need one equation to match the number of variables and equations in the original condition, the equal number of equations and variables should logically lead to answer D. Let's apply the 3 steps suggested previously. Follow the first step of the variable approach by modifying and rechecking the original condition and the question. We have to find the number of male students who did not have brothers. This condition is currently the most frequently appearing question type on the GMAT math section. We call this a complementary 2 by 2 question. Let's first draw a table like the one below and assign variables for the different sets of students as shown. Boys who have brothers is A. Girls who have brothers is C. And the total is 55. Boys who have no brothers is B. Girls who have no brothers is D, for a total of 45. The total of boys is 40, and the total of girls is 60, and the total of all is 100. So we need to determine the value of B, which is the number of boy students with no brothers. This question seems a little complicated, but it is actually quite simple if you know the structure and apply the variable approach. Follow the second and third steps. From the original condition, we have 4 variables, A, B, C, and D, and 3 equations. C plus D equals 60, A plus C equals 55, and A plus B plus C plus D equals 100. To match the number of variables with the number of equations, we need one more equation. Since conditions 1 and 2 will provide one equation each, D would most likely be the answer. Recall 3 principles and choose D as the most likely answer. Let's take a look at each condition. Condition 1 tells us that 30 students are girls who have brothers. Therefore, C equals 30. And if we substitute this into the equation A plus C equals 55, we get A plus 30 equals 55, or A equals 55 minus 30, which equals 25. We can then substitute this value for A into A plus B equals 40, giving us 25 plus B equals 40, or B equals 15. Since it is a unique answer, this condition is sufficient. Condition 2 tells us that 30 students are girls who do not have brothers. That is, D equals 30. Substituting this in original condition, A plus B plus C plus D equals 100, we get A plus C plus B plus 30 equals 100. But we know A plus C equals 55. So 55 plus B plus 30 equals 100. That is, B equals 15. Since it is a unique answer, this condition is sufficient. Each condition alone is sufficient, so D is the correct answer. Answer D.